So a little more progress on the 128 driver. I found that the RS-232 signal, I didn't know this, I'm learning as I go, it actually swings from negative 12 volts to positive 12 volts, which is this huge 24 volt AC signal. The reason it was designed with that spec is because then you could run very long serial cables and the signal to noise was really good. But for my logic analyzer clone, that didn't help at all, because it's expecting TTL style logic, which is 0 to 3 or 0 to 5 volts, which is fine with, but 24 volts is really brutal, right? So I had to put together this little circuit with a Max 232 chip. And what this guy does is it converts the 24 volt swings into that TTL logic with 5 volts. It requires a handful of capacitors and a small circuit, but it actually works really well. This is designed to go back and forth from that TTL logic to the negative positive 12 volts. So in theory, I could write 5 volts to this and communicate to the RS-232 port, but I really don't care about that because I'm just listening for reverse engineering purposes, and then I'm actually using the computer itself to send signals to this to go to the 128X. So as long as I can receive, that's fine. And there's 2 channels for receiving and sending on this, so that works out. I listen to the TX and RX and just totally ignore sending data. But anyway, so I have that fixed, which is important because what I didn't realize before was that I was having all kinds of frame errors, right? Because all the distortion in the logic analyzer's inputs was causing data to be read incorrectly, but now it works fine. So this is actually what the data looks like without frame errors. If you compare it to my last video, you'll see that there's no errors channel here because there are none, which is really, really, really good. And I found out that the 128X is actually half duplex. And again, I'm learning as I go. I didn't really consider what half duplex meant because it didn't concern me, but that means that you can only read or write one or the other. You can't read and write, which the serial protocol does spec for, but this piece of hardware doesn't use it. So I've neatly labeled these pins, right? Here's RxTX. If you look at this, it's receiving, it's sending, it's receiving, it's sending, but it never does it at the same time. That's intentional. It can, it's different ports, but the hardware doesn't work that way. And one of the ways to accommodate for this style of communication is by using RTS and CTS, which stands for request to send and clear to send. So in other words, if you want to send some data, then you have to request the ability to send it to it, and the device has to come back and say, all right, I'm ready, and then you send data. But it looks like the 128X, again, I'm learning as I go, does this in kind of an odd fashion. As you can kind of see, the request to send, granted this is recording directly, right? This is not anything I made up, this is just listening. The request to send happens after a little bit of TX, or transmit, goes on here. So it transmits a little bit, then it hits request to send, and it receives and does all this stuff when clear to send is, yeah, so I don't really know, and honestly I don't really care either. As long as I can mimic something that works and I can reverse engineer it, if it's like breaking protocol specs, that's fine, whatever, who cares. So I learned something really important. I totally ignored these 2 pins, which are 2 extra pins off the serial port designated for these 2 channels I just mentioned. And yeah, I am bringing this like crazy 24 volt fluctuation right into the logic analyzer because fuck it, it works. And the initialization sequence is much more than just some transmitting bits that I found in my last video. In fact, what it does is this really oddball synchronization thing with the request to send. So this clear to send thing is always fluctuating. Like it's sending a solid signal. It's really strange. In fact, this is the recorded data just so I can look at it, and this is the logic analyzer live so I can debug it. But if I hit run here, you'll be able to see that wave, I think. There we go. Okay, so this is actually a wave that's being sent from the 128X right now. Yeah, some proof to that. Here it is. It's powered on. I turn it off. I'm going to turn it off. And it dies. Turn it on. It goes through its init sequence, and then it starts back up again. So there's this really strange initialization routine that happens where you have to send a request to send that mimics a few of these, what do they call them? Shelves? What? That's not right. Edge. You have to like make the edges of request to send sync up with this, and then this clear to send goes low. Then you send all this crazy stuff and you sync it up. I haven't gotten that far, but then it starts doing data. Before this, I was actually sending this stuff to it directly, and when I went to receive data, it would hang because it was trying to listen for data, but it wasn't getting any because I didn't initialize it correctly. So anyway, I figured out how to initialize it, I think. I'm still doing development on that, but here's what I got going. So if I hit run here, it gets that weird wave. I have some code in here, and what this guy does is it tries to do that thing where it mimics the wave. It's got a really wasteful 100% CPU loop in there that I plan on killing, but I just wanted to test it out. But if I run this function, this init function I wrote in a console, it seems to do the job. So here I'll run init, and over here I'll watch what's going on. I hit enter, and it does that thing. There it goes, off the scale. But now this light turns on. That's cool. So let's try that again. In fact, I'll just, instead of doing that and watching for this wave, let's take a look at the 128X now. So I go here, run that init function, and bam, turns on. So that's great. I'm happy about that. Not knowing about the RTS and CTS spec and serial at all, and not knowing that this thing was half duplex, and not knowing that it was using that the whole time, really kind of made me waste some time, and I was getting really bored not knowing why this wasn't working, so I'm excited to have this. Yeah, so that's the progress so far. So right now, it's waiting for this stuff. This is like the real data, right? So the next steps are to play this data into here while controlling this clear. Oh wait, that clear to sends come from the 128X. Anyway, I'm going to mimic this stuff, put it into here, and just see if I can make it respond the same way as this. And instead of taking the data from here that it's receiving, so this part's receiving, this is sending. Same up here, right? This is receiving, this is sending. I want to just read this and kind of like see that it exists, but I don't really care about the data right now. I just want to be able to get these packets back from the driver or from the 128X and just have something to play with. From there I'll be able to reverse engineer the next steps. But if I am able to make that stuff come from this code, then I'll be able to basically get the same data as in whoops. Oh. What's going on there? Maybe it needs to reset. There we go. Okay, so I'd be able to get the same data of here, from here. I just make it go nowhere instead of to an interface for now. In the future, I plan on making a mock-up of this. But yeah, that's my progress, and it's coming out pretty good. All right, thanks again for watching.